All right, welcome. This is our last lesson, 4.4, Applications of Linear Equations. So we're going to do some word problems, which is nice because it's things that you could possibly use. Okay, so you want to use the given information to decide how to write linear equations in slope-intercept form. The most important features needed to write an equation in slope-intercept form are obviously the slope and the intercept, y-intercept, okay? Okay. Kind of talked about this a little bit, but words that indicate slope are words like rate of change or per. This is an often common one. Or for every, each. Like I get paid $10 per hour or each hour. Or I'm running 10 miles per hour, or I'm driving 10 miles per hour, or a lot of stuff like that. Okay, so look for values that occur often, like monthly payments or stuff like that. Okay, and then we have the y-intercept can usually be found by looking for values that occur just one time, like a membership fee or the beginning of a time period. Like oftentimes we'll have the word initially, like initially he had $150 and then or he won $20 or something like that. Thing that you get one time, and then we use that slope to increase or decrease. Okay, so let's just get into a problem. So you plan to walk home after school, which is approximately 6 miles away. So here's a number. It's probably important. Okay, and you walk approximately 3 miles per hour. Okay, so this is a rate. This is our slope. Okay, per is kind of our keyword. All right, so we want to, first I'm going to ask you to identify the variables in this situation. So what does x represent? Well, x, and again, a key thing is that x, if time is in it, x is always time. Okay, you can't change time. It's the independent variable. You can't change it, okay? So here if we have time, then that will always be x. So here we have hours, okay? And y is going to be our miles, all right? All right, so let's see what's next. What is the given information for this problem? What is the y-intercept and what's the slope? So the y-intercept again is always going to be like your initial value. Okay, so initially he's 6 miles away. So we'll say the y-intercept is going to be 0, 6. And the slope here is going to be our rate. Okay, so that's our miles per hour. So our slope here is going to be 3. Okay, we always need to think about whether it's going to be positive or negative. Okay. All right, so you're walking home. Let's kind of draw a picture of what's going on. We have our y-intercept here is 0, 6. Okay, and we want to get home. So we're going to have to, and we're going to say that this is our distance. Sorry, this is our time. My bad. This is our distance, and this is our time. So we're going to, in some way, we're going to want to come home. So we want our distance to go to 0. So our slope here is going to need to be 0, or sorry, negative. Okay? All right, so we want to write an equation to model this situation. Okay, well we know y equals mx plus b, so y is equal to negative 3x plus 6. Okay, it says write down the x and y intercepts, and what do they represent? So we already have the y-intercept was 0, we'll write it here, y-int is 0, 6. And what does that represent? Well, it represents how far he is initially, the distance initially. At time equals 0, he's 6 miles away. Okay, and you could even write it that way. So at time is 0, he is 6 miles away from home. Okay, something like that. And then for x-intercept, okay, we would need to solve for that. So, because we don't know what that is initially, they don't give us that information, how long it would take them. Okay, so here we would need to say, if it's x-intercept, we know that y is equal to 0. So we'd do 0 is equal to negative 3x plus 6. And we'd need to solve for x. So we'd subtract 6 from both sides. And then we'll divide both sides by negative 3. And we end up getting x is equal to 2. So our x-intercept here, x-intercept is going to be 2, 0. Okay, and what does that represent? Well, it represents that after 2 hours, he is home. Okay. All right, and then we want to, I'll always have some sort of problem that you would want to use your equation. So use the equation from A that you came up with, I guess you got it there, okay, to figure out how far away will you be after walking 1.5 hours. Okay, so we just evaluate that. So again, hours is our x, okay, it's our time. So we'll say y is equal to negative 3x, well x is 1.5, and plus 6, because that's from our equation above. Okay, and we'll just evaluate. So negative 3 times 1.5, 3 times 1.5, okay. I'm okay if you have decimals, so that gives us negative 4.5 plus 6. And here would end up getting, what does that give us? Plus, it gives you 1.5, okay? So that tells us that after walking for an hour and a half, he is 1.5 miles away from home. So let's kind of look at this. Let's graph this and make sure this makes sense. So if we put our x-intercept, what we said is 2, 0, and or we could also just use our slope. So our slope is negative 3. So every would go down 3 over 1, down 3 over 1. Okay, and then after walking for an hour and a half, should be right here, it tells us that we are 1.5 miles away from home. Okay, so we can always check that way by graphing visually. Okay, all right, so let's try a couple others. Probably won't do all of them, but I'd like you to give a try on some of them. Okay, so let's do one more together and then we'll have you do a couple. All right, so suppose you receive $100 for graduation from your grandparents, $50 from your parents, and $200 from Mr. Warner, because I'm just so nice, okay? So that gives you a total of how many dollars? That's $350, okay? You're a planner and you decide to deposit it in a savings account. Afterwards, you spend $50 per month to pay your cell phone bill, okay? So first off, what is x and what is y? What are the variables? What do they represent? Okay, so x, again, if we have time, it's going to be x. So x, we have months. Okay, so it's going to be our time. Would be months. So I'm going to label that here, months. And then y is kind of like your initial value, so it's dollars. All right. y-intercept would be initial value, which would be 0, 350. So let's plot that. And then the slope says $50. And we're spending it, so we're losing that money. So negative 50. Okay, if you were like saving $50 more a month, then it'd be a positive slope. All right, so write an equation that models that. So we could do y is equal to mx plus b, right? We really could just already graph, because we know the slope is down 50 over 1. So let's just do that just for the heck of it and see what we're looking at. Okay. On your test, I may not give you a graph to do that. So if I asked you to find out the x-intercept, then you would need to do it by hand, and I will do it here as well. So we'll just verify. So it says write down the x and y intercepts, and what do they represent? Well, we already have the y-intercept. That was 350, gosh. And that would represent the initial amount of money he has. Initial money he has is $350. Okay, and if we want to find the x-intercept, we would need to set y equal to 0. So for x-intercept, we know y is equal to 0, so we do 0 is equal to negative 50x plus 350. So then we would subtract 350, and then we would need to divide both sides by 50, negative 50. Okay? And that ends up giving us x is equal to 7. So our x-intercept is going to give us 7, 0. And what does that represent? And we can check and make sure it's there. Yep, we got it just right. And what it represents would be something like after 7 months, he is out of monies. Okay? Use your equation to find when you will have $100 left in your account. All right? So again, dollars is our y value. So we're going to need to plug that into our equation. You could also look at your graph, but I'd like you to do it by hand because that's how you'll probably need to do it on the test. Okay? So here we'd set y equal to 100. 100 is equal to, and we use our formula, our equation we wrote down, negative 50x plus 350, and we'd need to solve. So we'd subtract 350. That gives us a negative 250 is equal to negative 50x. And then we just need to divide both sides by negative 50. And we'd end up getting x is equal to 5. So after 5 months, he has $100. Okay, and we just verified that by using our graph. All right, so I'd like you to practice, see if you can do 3 and 4 by yourself before I let you go to work on your homework. All right, so hopefully you gave this a try. Please give it a try if you haven't yet. Okay, the babysit. I don't know if that makes sense, but you are paid as a babysitter. Maybe we'll say that, as a babysitter. You are paid $5 per hour. Okay. You save everything you earn, and you initially have $15. okay? So what are our variables? What do they represent? Okay, so x, again, if we have time, looks like we have hours. Okay, and y would be, it looks like, it's always going to be what we do for our y-intercept. So here is dollars. Okay, what's the y-intercept? Well, initially, you have $15, so that'd be 0, 15. At time 0, we have $15. And the slope here is going to be 5. It's going to be positive or negative? It's going to be positive because she's earning. She's not losing that money. All right? Okay, so we want to write our equation. So y is equal to mx, so 5x plus 15. Okay, we can plot that y-intercept would be right here. And we know our slope is 5. So it looks like it's just going to look something like this. All right, it says write down the x and y intercepts. So we know the y-intercept already is 0, 15. So that's initially she has $15. Okay, that's what it's telling us. This is initially at time equals 0. She has $15. Now we want to find the x-intercept. It's not on our graph. Okay, it's somewhere over here. All right, we're going to show our work by using our equation. So if it's the x-intercept, we know that y is equal to 0. So we do 0 is equal to 5x minus 15. We would add 15 to both sides. And we'd get 15 is equal to 5x, and we'll divide both sides by 5. So we end up getting x is equal to 3. So our ordered pair would be 3, 0. Okay, and how we'd represent that? Well, this one doesn't really make sense because we never, oh, sorry, that's a negative 3. We never have negative time. I guess you could say if she had been like doing babysitting before that, that means that like maybe 3 hours of babysitting, that's what she had initially, or 3 hours ago, she had no money. I guess you could say something like that. But typically, if it is negative time, we will just say it doesn't apply, okay? We're only going to look at initial value and onward, okay? All right, so you have a goal of saving $1,900 for college. How long will it take you to save up that much using your equation? Okay, so we want, again, dollars is our y's. So we're going to do 1,900 is equal to 5x plus 15. Right? And we're going to solve to figure out how many hours it takes to give us our $1,900 or $1,900. Okay? So we will subtract. Again, we take away what's furthest from x. That gives us 1,885 is equal to 5x. And then we'll just divide both sides by 5. So you get your calculator out. And you'll get something like x is equal to 377 hours. So if you wanted to save that much money, you would need to babysit 377 hours. If you divide that by days, that's like almost 16 days. So you'd have to be babysitting constantly for that many days, which is kind of crazy. But you can do it. You can save that money to go in college. Okay? All right. All right. I'd like you to, if you haven't yet, do one of these, okay? And just as a practice, I'll probably go a little quicker on these, okay? Just so you can check your work. Okay? So Nick is given $50 to spend on vacation. He spends $5 a day. So here, a day dollars a day. That is a rate, okay? So that would be our slope, and he's spending it, so he's losing $5 a day, okay? Again, X is going to be our time, this will be days, and this will be our dollars. It seems like Y is dollars a lot. Our initial value here would be 0, 50, okay? Because initial money is $50. Equation here would be Y is equal to negative 5X plus 50. We want to write down our Y-intercepts. We already wrote that here. So what it represents is initially he has $50. Okay, and then we'd want to find the X-intercept. Okay, that's when Y is 0. So X-intercept, Y is 0. Okay, so we'd get 0 is equal to negative 5X plus 50. We'd subtract 50 from both sides. And we'd divide both sides by negative 5. And we'd get X is equal to 10. So our X-intercept would be 10 comma 0. So this is saying after 10, whatever our X unit is, days, 10 days, he has run out of money. Okay. Use your equation to find out when Nick will have $10 left. So again, that's our Y. Dollars is our Y's. So we would do 10 is equal to negative 5X plus 50. So we'd subtract 50 from both sides. Negative 40 is equal to negative 5X, and we'd divide both sides by negative 5. So here we'll end up getting X is equal to 8. So after 8 days, he has $10 left. Let's graph this and see how this all turns out. So 0, 50, that's our initial value. And then it has a slope of negative 5. So it goes down 5 over 1. Okay. Connect all those dots. Okay. We can check our X-intercept. We said it was 10, 0. Check. And then we can also check with $10 left. He had after 8 days. It took him 8 days after he has $10 left. Okay, so we can check it that way. Again, I'm requiring you to show your work, okay, and then verify using your graph. All right, and I'll finish this one up too if you wanted to go over it. Amy sells bread to make some extra money. Ingredients cost her $65. So she can sell each loaf of bread for $5. So what are our variables? Identify the variables. So we don't have time this time, okay? But let's look at our rate. So loaf of bread for $1. So it's $5 a loaf. Okay. And here would be our initial value. So our initial value, that always will tell us that our Y is dollars. So this must be loaves. Did I spell loaves for multiple? Okay, I think maybe. Anyways, okay, so we have dollars, and here we have, oops, I get it right. This is dollars. And this would be our loaves of bread. This is my loaf of bread, just so you know. Here's a nice slice of bread. All right, okay. So we want to find our initial value, our y-intercept. So that would be 0, comma. And here she has to spend money. So she loses money to buy the stuff. So that would be a negative thing. Okay, so initially she is like in the hole $65. She hasn't earned any money, okay? She lost it, okay? And the slope here, she gets $5 a loaf. So that's positive, okay? It helps her up. So let's plot this first one, negative 65, and then it has a slope of 5. So it goes up 5 over 1, up 5, 1. So it's going to look something like this. All right, so we want to write our equation. So that would be y is equal to 5x minus 65. The y-intercept here, okay, that tells us that initially she is in debt $65, okay, assuming that she had to borrow to get the money, okay. Maybe I should have added that ingredients. She borrowed $65 for ingredients. Okay, and then the x-intercept, we would solve for it, so we'd do x-intercept, we know that y is equal to 0, so 0 is equal to 5x minus 65, would add 65, and then would divide both sides by 5, and would end up getting x is equal to 13. So the x-intercept would be 13 comma 0. That tells us that after selling 13 loaves, she got out of debt. Okay, so use your equation to find how many loaves of bread Amy has to sell to earn $50. Okay, so we want, again, loaves is x, and dollars is our y's. So we'd set y equal to 50. Okay, so we would add 65. That gives you 115. And then would divide both sides by 5. So 115 divided by 5 gives us x is equal to 23 loaves. So she'd have to sell 23 loaves to get $50. Right? All right, well, if you have any questions, let me know. Your homework is going to be similar to that. I'll have like all of these things that you'll need to do. I think there's maybe 4 of them, okay? I know it kind of takes a little bit, but you got it. Let me know if you have any questions.